Dear students, welcome to one-shot series of industrial engineering. This is the fourth lecture called sequencing and assignment. So quickly going through, because I'm introducing in every lecture. This is our team Drona, expert of every subject. So the topics that I'm going to cover in today's lecture are, I want to give you some background why we require this study in industry. Suppose we are solving the problems on assignment and sequencing. So practically where it is used in industries. Now we will discuss some questions on assignment. Then SPT, shortest processing time. SPT means shortest processing time, and sequencing, that we will go through a little bit. Then multiple machine sequencing problem also we are going to study. Multiple machine sequencing problem we are going to study. So this is a very small topic for industrial engineering. Very small topic of industrial engineering. And the good thing about this topic is, variety is not possible. Variety is not possible. So first 4 lectures of industrial engineering we have done graphical, then simplex, then transportation. This is the 4th one in the series. Variety is not possible. But the coming 4 lectures of industrial engineering, lot of variety is possible. That is the way I have designed. That first 4 lectures, no variety. Whatever pretty much we are doing in the one-shot series, little bit data change here and there, questions are going to come in exam. Okay, so these are my qualifications. I am gold medalist from AMU, Aligarh Muslim University. I am MTech and PhD from IIT Delhi. Between MTech and PhD, I was IAS officer. But I am a researcher. I do research in material characterization. So now, let us discuss the background. Where exactly sequencing and assignment problems are used in industry? See, there are some flexible manufacturing systems. There are flexible manufacturing system. In one crash course, I have covered automation to a great degree. I am giving only a small window here. Flexible manufacturing system is meant for batch production. It's meant for batch production, and every design change can be accommodated in the system very easily. Suppose there is some design change of any product, that design change can be accommodated very easily in the system. So what are the requirements of flexible manufacturing system? What are the requirements? Any production system can be converted into flexible manufacturing system only when the production system is having some facility. First facility is all the machines should be CNC or NC. All the machines should be NC or CNC. Second requirement, there has to be a DNC system, direct numerical control or the distributed numerical control. Direct numerical control or the distributed numerical control. So DNC system is a mainframe computer, and everything in the plant is connected to this mainframe computer. Everything in the plant is connected to this mainframe computer. Third requirement is material handling by automatic guided vehicles. Automatic guided vehicles, AGVs, we call it popularly AGVs. And finally, there has to be a simulation support. There has to be a simulation support. So now there is a FMS system and multiple CNCs are working there. Let us say CNC1, CNC2, CNC3, CNC4, CNC5. Now, each and every machine is connected with the help of a track. Each and every CNC is connected with the help of a track. And the track is segmented. Track is segmented. And automatic guided vehicles moves over these tracks. Automatic guided vehicles moves over these tracks. Now, for every CNC, there is an input bin. There is an input bin. Bin is also called buffer. And there is an output bin. Input bin and output bin. And each and every bin will have fixed number of stations. Station 1, Station 2, Station 3, Station 1, Station 2. Each and every bin will have fixed number of stations. So what exactly happens? On every CNC there is a robot. On every CNC there is a robot. Flexible manufacturing system. Varieties of parts are being produced simultaneously. Varieties of parts are being processed simultaneously. In FMS, not the single type of products. Varieties of product are being processed simultaneously. So there will be a DNC system. And everything in the plant, from the raw material, CNCs, AGVs, robot, everything is connected to this DNC system. Raw material is supplied from this side. Raw material is supplied from this side. So varieties of raw material are being processed simultaneously, and the final product goes out from this side. Final product goes out from this side. So now the robot working on the CNC, he will work on some strategy. So part entry control strategy by robot. Part entry control strategies. What is a part entry control strategy? The sequence in which robot will pick up the raw material from the input bin and place it on the machining center. And after machining, same robot will pick up the semi-finished assembly and place in the output bin. place it in the output bin. Now there is an automatic guided vehicle. Before any raw material is converted into the finished product, it has to go through at least 2-3 machines. So it is called routing. Route a raw material has to follow in any flexible manufacturing system. So what this AGV does, AGV will pick up the semi-finished product from the output bin of any CNC. AGV will pick up the semi-finished good from the output bin of any CNC, and as per the routing, it will be placed in the input bin of another CNC. Input bin of another CNC. So AGVs are carrying the semi-finished good and moving within the plant. So there are different types of part entry control strategy. One is the shortest processing time, SPT. So robot will say number of varieties of products waiting in my queue, which is having the shortest processing time. Pick it first and place it on the machining center. SPT. Second is the earlier due date, EDD. Earlier due date. The part that requires to be dispatched early, pick it first. It is called EDD strategy. Then first come first serve. The part that came in first has to be processed first. Another is a last come first serve. Now to decrease the machine idleness, sequencing and assignment, we follow SPT technique, shortest processing time technique. So whatever procedure I am going to tell you, whatever procedures I am going to tell you in the assignment and sequencing, it is basically nothing but SPT technique of part entry control strategy. But for EDD also there are techniques, but primarily we are going to follow SPT, shortest processing time. So sequencing and assignment have lot of application in flexible manufacturing system. So for the detailed study, because here it's an industrial class, detailed study in the crash course I have covered these things. In the crash course I have covered these things. Okay, na? So this is the background. Now let us look at some problems. Assignment and sequencing are the easiest topic in industrial engineering. Okay. So first of all, assignment. There are 5 machines and the 5 jobs. And these machines are machining centers. Now there is another question, what are machining centers? Machining centers are at least 2.5 axis machine. Meaning contouring can be done in 2 planes. This is one plane, this is another plane. And the simultaneously linear interpolation can be given in the 3rd direction. It's a 2.5 axis. For details, see our automation lectures of crash course. So each machine can process any of the job. But some machines will be specialized machine. Job 1 can be processed on machine A, but it takes 6 minutes. But job 1 can be processed on machine B in just 1 minute. Because some machines will be a specialized purpose machine to take care of certain types of jobs. Same job, when it is processed on machine C, takes 16 minutes. So it's a matrix that which job is processed on which machine, how much time it will take. How much time it will take. So the assignment problems are which job needs to be assigned to which machine, which job needs to be assigned to which machine, so that the total processing time is minimum. Which job needs to be assigned to which machine, so that the total processing time is minimum. Total processing time is minimum. So here also there is a condition. Here also there is a condition that to begin with, my matrix must be square. It must be a square matrix. To begin with, my matrix must be a square matrix. My matrix must be a square matrix. If the matrix is not a square one, if the matrix is not a square one, I add dummy rows and dummy columns. Similar to the transportation, I add dummy rows and dummy columns. But fortunately, my first column has got a square matrix, so I don't have to worry about it. Okay. Now, what I should do, let us begin iterations. Let us begin iterations. Table 2. A, B, C, D, E, 1, 2, 3, 4, 5. So I am beginning the iterations. Look at carefully how I am doing the iterations. I am doing the iterations now. Select, look at the board, what I am doing. Select minimum value of each row. Select minimum value of each row and subtract it from each and every element. Select the minimum value of each row and subtract it from each and every element of that row. So let us do it. The minimum value here is how much? 5. In the first row, the minimum value is 5. So subtract 5 from the first row. Subtract 5 from the first row. 1, 0, 3, 6, 11. Correct now? 5 is the minimum value in the first row. Subtract 5 from each and every element. You will get these values. In the second row, minimum value is 1. So subtract 1 from each and every element of row 2. Fly. So now subtract 1 from each and every element of row 2. 0, 12, 15, 0, and 9. Correct, na? Once again, assignment and sequencing, these are basically one of the most easiest problems in industrial engineering. Just see the procedure. No, variety is not possible here. Third row, minimum value is 8. Subtract 8 from each and every element. 8, 3, 0, 0, 0. From fourth row, minimum value is 9. Subtract 9 from each and every element of fourth row. 0, 5, 3, 1, 7. Now in the fifth row, minimum value is 8. So subtract 8 from each and every element. Okay? This will make sure, this step will make sure that in each and every row there is 1 0. Each and every row there is 1 0. Now you check the columns. You check the columns that whether at least 1 0 is there in each and every column. 0 is there, 0 is there, 0 is there, 0 is there, 0 is there. So you have to make sure that each and every column there is at least 1 0. And in some column, let us say if 0 is not there, let us say in some column if the 0 is not there, same procedure you repeat for the column. What is that procedure? Select the minimum value from that column and subtract that minimum value from each and every element. You will get 1 0. So for iterations, 1 0 must be there in each and every row and each and every column. Then the first step is over. At least 1 0 should be there in each and every row and each and every column. Correct? Now the next step is cover all these 0. Here we have to think little bit. Here we have to think little bit, because otherwise here most of the students do mistakes. Cover all the zeros. Cover all the zeros with minimum number of lines. Cover all the zeros with minimum number of lines. So see here, 3 zeros are covered. 2 zeros are covered. 2 more zeros are covered. This is left. So what is the next step? Cover all the zeros with minimum number of lines. In exam, what I suggest you take one HB pencil. And with the HB pencil, you try to draw lines. In the first iteration, lines may be wrong. So it's delete it and then again draw. So this step requires little practice. Covering all the zeros with minimum number of lines. Correct? Now, if number of lines if number of lines is equals to order of matrix, if number of lines is equal to the order of matrix, then it's an optimum matrix. Then it's an optimum matrix and the decision can be taken. But if the number of lines are less than the order of matrix, further iterations are required. If the number of lines are less than the order of the matrix, it means further iterations are required. Okay? Number of lines are 1, 2, 3, 4, 4 lines. Order of matrix is 5 here. Order of matrix is 5. Correct, na? So this matrix is not an optimum one. If the number of lines are less than order of matrix, it means matrix is not an optimum one. Further iterations will be required. Further iterations will be required. Okay. Now, for further iterations, what exactly we do? In the one shot, as I am speaking, you should also write and solve along with me. That is the best way to utilize this one shot series. This is the best way to utilize this one shot series. Okay. So now next iteration, what we will do? Here carefully. Select the minimum number. Select the minimum number not covered by the lines. Select the minimum number not covered by the lines. So see, it's a 3. 3 is the minimum number not covered by the lines. Correct, na? This number, subtract this number from all the non-covered elements. Subtract this number from all the non-covered elements. Correct, na? Subtract. And add this number at intersection points. Add this number at the intersection point. What is the intersection point? This one, this one, this one, this one. Add at the intersection point and subtract it from the uncovered element. So let us do it. 3. Remaining will be as it is. 0, 11, 0, 2, 0, 9, 3, 2, 2, 3, 12, 0, 0, 0, 9, 0, 3, 1, 0, 11, 6, 0, 4, 7. Select the minimum element from the uncovered numbers, subtract it from each and every element, and add at the intersection points. You have got a new table. You have got a new table. Again do the same operation. Again do the same operation. What is that? Covered all the zeros. Covered all the zeros with minimum number of lines. See, whatever the way you draw, number of lines will be 5. Whatever the way you draw, number of lines will be 5. Whatever way you draw, number of lines will be 5. Okay? Now what we do, the matrix is ready for assignment. This matrix is ready for assignment. So make it again. I think that will be good if you make this matrix again. If you make this matrix again, that will be great. 4 0 11 0 2 0 9 3 2 2 3 12 0 0 0 9 0 3 1 0 11 6 0 4 7. Now this matrix is ready for assignment. This matrix is ready for assignment. We make assignments. We make assignments on zeros only. We make assignments on the zero only. So machine A, there is only 1 0 appear. So A will process machine job 2. Now after making the assignment, one thing you have to remember, that A machine I have assigned to job 2. After making the assignment, you have to be careful that remaining zeros in that row and that column will be cancelled. After making assignment, remaining 0 in that row and that column will be cancelled. So there we don't have any option. A machine A has to be assigned to job 2. Okay. Now B, there is 1 0 here, there is 1 0 here. So let us say assign to job 1. So this 0 will be cancelled, this 0 will be cancelled. So B has to be assigned to job 1. C, there are 2 0, 1 0 here, 1 0 here. C, if you assign here, these zeros will be cancelled. These zeros will be cancelled. So for D, no assignment will be left. Correct, na? C, if you assign this 0, the remaining 0 will be cancelled. So for D, there is no 0 left. So C assignment, I will not make it here. I will make it here. So this will be cancelled. So C will be assigned to 5. D will be assigned here. D will be assigned to 3. And E will be assigned to 4. So what is the assignment? A is to 2. Assignment is 21534. This is the first assignment, okay? But see, there are alternate solutions. There are alternate solutions. To find out the alternate solution, I'm making this matrix again. 4 0 3 9 11, 4 0 3 9 11, 0 9 12 0 6, 11 3 0 3 0, 0 2 0 1 4, 2 2 0 0 7. Okay. Assignment can be done only on zeros. So A, anyway, we don't have any problem. Assignment 1. So what I'm telling you, it's an alternate solution. Alternate solution. So A is to 2, here also A is to 2, we don't have any option. This B, let us make assignment here. So B is to 4. C, let us assign here 5. D 0 0. If I assign 0, this will be cancelled. That I don't want. D is to 1 and E is to 3. So there are alternate solutions, okay na? This is the first assignment and the second assignment. Alternate solution means both the assignment will give me the same solution. Now, if the question is asked, how much is the optimum minimum processing time? So this assignment you project to the original matrix. A is to 2, B is to 1, C is to 5, D is to 3, E is to 4. So total time, optimum time will be 5 plus 1 plus 8 plus 12 plus 8, 20, 30, 4. Correct, na? 34. Projected on the original matrix. Okay. So this is the procedure that how we allocate the machines to different jobs, so that my minimum processing time, my total processing time is minimum. So this is the case when your matrix was square. This is the case when your matrix was square. Let us say when the matrix is not square. Let us say when the matrix is not square. This is another question. Once again, variety is not possible in GATE also. So whatever we are discussing in one shot, if you can remember the procedure, you will be able to hit every single problem in assignment and sequencing. machine 1, M2, M3 and 4. There are 5 jobs. 1, 2, 3, 4, 5. There are 5 jobs. Nine, 12, no. 14, 11, 9, 11, 8, 15 dash, 14, 12, 10, 10, 11, 7, 11, 9. Okay. So it is not an optimum matrix, square matrix. Okay. You know, what is the meaning of this dash? What is the meaning of this dash? Dash means job 3 cannot be processed on machine 2. Or you can say infinite processing time. Cannot be processed. So we will not make this assignment, and numerical value we will take it as infinite. Job 1 cannot be processed on machine 3. Cannot be processed on machine 3. Simplex problems are meant for profit maximization. We discussed. Transportation problems are meant for cost minimization. Assignment problems are also loss minimization. Assignment problems are also loss minimization. But suppose profit matrix is given to you. Suppose the profit matrix is given to you. We will exactly follow like that of transportation. We will exactly follow like that of transportation. What is that? Select the maximum value in the matrix and subtract each and every element from that maximum value. Select the maximum value, and from that maximum value, select each and every element. You will get a loss matrix. So when the profit matrix is given in assignment, we have to convert it into a loss matrix similar to the transportation problem. And we will operate on the loss matrix. We will operate on the loss matrix here. Now, there is one more thing. There is one more thing. This matrix is not an optimum one. This matrix is not an optimum one, not an square one. So there are 5 columns and the 4 rows. So to make it square, add a dummy machine. Add a dummy machine. Dummy machine will consume 0 time. Dummy machine will consume 0 time. So you make a square matrix by adding a dummy row or dummy column. Correct, na? Matrix must be square before we operate. Matrix must be square before we operate. Okay. Each and every column is already having 1 0. Each and every column is already having 1 0, so we don't have to do the column operation. We don't have to do the column operation. So next table, M1, M2, M3, M4, and the dummy machine jobs are 1, 2, 3, 4, 5. These are the jobs. Do the row operation. Dash means infinite. First row, minimum number is 5. Subtract 9 from each and every element of the first row. 0, 2, 6, 1, 2. Okay. Second row, minimum number is again 9. So subtract 9 from each and every element. Dash 1, 0. Third row, the minimum element is 7. So subtract 7. Fourth row, minimum is again 7. And fifth row, anyway, there is 0 everywhere. Now cover all these zeros with the minimum number of lines. Cover all these zeros with minimum number of line. This is covered. Whatever way you try, number of lines will be 5 is equals to order of matrix. Whatever way you try, giving you 15 seconds time, you try other methods also. Number of lines will be equal to 5 only. Number of lines will be equal to 5 only. Try. Try. So now let us make assignment, because number of lines are equal to number of lines are equal to order of matrix. So make assignment. M1 to job 1. M2, if I assign here, all the zeros will be cancelled. No 0 will be left for M3. So I cannot assign here. Assign here. M2 job 2. M3 assign here. Job 5. M4 job 4. Dummy machine job 3. So job 3 will not be allocated on any machine. So this is the assignment, and total time projected over the original M1 to 1, M2 to 2, M3 to 5, M4 to 4. So 9 plus 9 plus 7 plus 7, 32. So that was the assignment, and assignment problems are very, very easy. In the first problem, I told you the basic procedure. And in the second column, I try to explain to you that either there will be infinity, either there will be infinity, or my matrix may not be square. My matrix may not be square. So as I told you 2-3 times, assignment and sequencing, variety is not possible. Now in sequencing, I have taken one P by Q. And this P by Q I have expanded. This P by Q I have expanded in the next sequencing problem. So with that help of that problem, we will learn many things in sequencing. I will speak, but first of all, see the data. It's a GATE 2018 problem. No, what I recommend to all of you is for 5 minutes you look at your computer screen. Assignment and sequencing problems are very easy. So you look at your computer screens. So this is the problem given. Job A, B, C, D, E, F. There are 6 jobs. Time to process the jobs for job A, 3 days. Due date is given 8 days. After 8 days, we need to dispatch it. Job B processing time is 7 days. And due date is 16. After 16 days, we have to dispatch it. Job C takes 4 days, and after 4 days, we have to dispatch. Similarly, D9, 18 days, we have to dispatch. So this data was given to you. So you know what was the question in GATE 2018? If SPT technique is followed, shortest processing time, if the SPT technique is followed, how many jobs will be tardy? Tardy means late. If the SPT technique is followed, how many jobs will be tardy always? That was the question. Okay. So now, if I follow SPT shortest processing time, look at the board. A is having the minimum processing time, so I will process A first. After A, C is having processing time 4, so I will process C. I will go to increasing order of processing time. SPT means whatever product is having minimum processing time, I will process it first, and I will go in increasing order way. After 4, 5, I will process E then. After 5, it is 7, I will process B. After 7, 9, I will process D, and finally F. So the sequence in which I will process the product is A, C, E, B, D, F. I will process in this sequence. Okay. Job A consume 3 days, C 4 days, E 5 days, B 7 days, D 9 days, and F 13 days. So now I will make a table that how much time one batch can be dispatched. In how much time one batch can be dispatched. So A, after 3 days it will be out. After 3 days, product C will come into the system, and the C consumes 4 days. So 3 plus 4, after 7 days, C will be dispatched. After C, E will come into system. E consumes 5 days. So 7 plus 5, after 12 days, E will be dispatched. After E, B will come into the system. B consumes 7 days. 7 plus 12, after 19 days, it will be dispatched. After that, D will be coming into the system. So 19 plus 9, after 28 days, D will be dispatched. And similarly, F will be dispatched after 28 plus 13, after 41 days. After 41 days, one batch can be dispatched from our workshop. A batch of 6 pieces will be dispatched in 41 days. This 41 is called make spend time. Understood what is the make spend time? Because in this particular slide, I am introducing many terms to you. In this slide, I am introducing many terms to you. So you have to be little careful. In this slide, I am introducing many terms. So this 41 is called make spend time. Now, if you add everything, 3 plus 7 plus 12 plus 19 plus 28 plus 41, if you add everything, summation is 110. This 110 is called total job flow time. So depending upon what question is asking, you have to give that a particular answer. So all the permutation and combination I have fit into this slide. All the permutation and combinations I have fitted in this slide. So understood what is the total job flow time? You add everything. And this last value, after which one batch will go out, is called make spend time. And the summation of everything is called the total job flow time. Okay. Now see here, job A will be dispatched after 3 days, means it will be dispatched on time because due date is after 8 days. C will be dispatched after 7 days, but it is supposed to be dispatched after 4 days. So C job will be tardy. Tardy means late. How many days late? We are dispatching after 7 days, but it was supposed to be dispatched after 4 days. So tardiness is 3 days. Tardiness is 3 days. E, due date is after 17 days, but we are dispatching after 12 days. So E will be dispatched on time. B, we are supposed to dispatch after 16 days, but we are dispatching after 19 days. So this job is also tardy. Tardy means late. How many days late? 19 days we are dispatching, but it's supposed to be dispatched after 16 days. So 3 days late. D, 18 days, but we are dispatching after 28 days. So it is also tardy by 10 days. F, we are supposed to dispatch after 19 days, but we are dispatching after 41 days. So this is also tardy. Tardy by 22 days. 41 minus 90, 22 days tardy. So by following the SPT technique, by following SPT technique, 4 jobs will be tardy always. 1, 2, 3, 4. By SPT technique, if we follow, 4 jobs will be tardy always. Job C tardy means late, 3 days. E on time, B 3 days, D 10 days, F 20 days. So total tardiness is 38 days. Total tardiness is 38 days. If the question is asking you about the average tardiness, question is asking about the average tardiness, total tardiness divided by number of jobs. Remember, this number of job is the total number of jobs, 6, not 4. 4 jobs are tardy always, but number of jobs are 6, na? So to calculate the average tardiness, so total tardiness divided by the total number of jobs, 6, not 4. Please remember this thing. To calculate the average tardiness, we have to divide by, to calculate the average tardiness, we have to divide by the total number of jobs, not the jobs that are tardy. So average tardiness is 6.33. 6.33. 6.33. Okay. So understand the different terms. Understand the different terms. And all these terms comes in GATE exam. How to calculate which term you are supposed to know. Now, average job flow time is total job flow time. See, after summation of all these things, this is the average total job flow time divided by number of jobs. Number of jobs are 6. Number of jobs are 6. So if average job flow time it is being asked, this divided by the number of jobs. That way you will calculate. Okay? Correct, na? Understand what are the different terms. That is the reason I have already written all the data, because in one go I want to introduce all the terms. In one go I want to introduce all the terms. That is the logic behind writing all these things on the board beforehand. Suppose the question is asking average number of jobs in the system. Average number of jobs in the system. Like in flexible manufacturing system, na, varieties of products are being processed at different stations. So if you want to know that how much is the average number of jobs in the system, now why we are interested to know the average number of jobs in the system? In flexible manufacturing system, if there are too many jobs in the system, in flexible manufacturing system, if there are too many jobs in the system, it creates a problem. And the problem is called blocking. What is blocking? I will explain to you what is blocking. After machining, robot is supposed to pick up the semi-finished product and place it in the output bin. But what robot finds that output bin is full? So robot is waiting for with the job that when the space will be created and I will dump the job into the output bin. This is called blocking of robot. Blocking. Now, one automatic guided vehicle AGV is carrying the item from output bin over the track and placing in the input bin of another CNC as per the routing. But what AGV finds that input bin is full. All the stations of input bin, there are products. So AGV is waiting for the space to be created. This is called blocking of AGV. So when there are too many components in the system, it leads to blocking. So this average jobs in the system tells you about the congestion. In the system. An average number of jobs in the system is nothing but total job flow time divided by make spend time. It is called MST. Make spend time is also called MST. So 110 divided by 41 is called average number of jobs in the system. It tells you about the congestion. In the system. Congestion leads to the blocking of flexible manufacturing system. Now, what I recommend to all now, whenever I started speaking this particular, it will be approximately 10 to 15 minutes. Please hear this at least 2-3 times. Things will be absolutely clear. Because if you are not from IITs and NITs, you don't study these things properly. That is the reason. So whenever I started explaining this whole thing, at least hear 2-3 times. Because there is an advantage, it's a recorded one. So everything is available on the YouTube. So this section, you can see it again and again. What is critical ratio? Critical ratio is the due date divided by the processing time. Due date divided by the processing time is called critical ratio. Suppose for B, due date, processing time is slack time is due date minus processing time. Suppose product A we are delivering on time. Due date is 8 and we are delivering on 3. So slack is 5. So the slack is 5. Correct, na? Slack means extra time available with the job before getting tardy. Slack time is the extra time available with the job before getting it tardy. Now slack available for E. Due date is 17. Because of fever, actually still the coughing is there. And we are delivering it at 12 days. So slack time is 5. Slack time is a 5. So in this particular sheet, I have explained everything related to nomenclature used in sequencing of one machine. One job, one machine. Okay. So last approximately 15 minutes, whatever I have spoken on this slide, I request to all of you that please hear at least 2 to 3 times. It's easy. Only you are supposed to know terms. That's it. Rest everything is easy. Rest everything is easy. Now let us move to 2 machine multiple job problems of sequencing. Another question. This is 2 machine multiple job problem. Two machine multiple job problem. Two machine multiple job problems. There are jobs A, B, C, D, E, F, G, H, I. Each and every job has to be processed on both the machine. Job A consumes 2 unit time on machine 1 and 6 unit time on machine 2 before it gets out. Job D takes 9 unit time on machine 1 and 4 unit time on machine 2 before it gets out. Now, in which sequence I need to process these jobs? In which sequence I need to process these jobs so that machine idleness is minimum? So there is a maximum utilization of the machines. In which sequence I need to process these jobs so that machine utilization is maximum. Machine utilization is maximum. Okay. So write the problem. We will do together. We will do it together. Okay. Similar to assignment, there are some rules here also. Similar to assignment, there are some rules. First is, you please hear what I am saying. I am speaking slowly. Please hear. In the matrix, select the minimum time. Select the minimum time. Oh, here is a minimum time. 2. Minimum time is 2. If the minimum time appears for machine 1, if the minimum time appears for machine 1, process that job first. If the minimum time appears for machine 1, process that job first. And if the minimum time appears for machine 2, process it last. Select the minimum time. And if the minimum time appears for machine 1, process it first. And if the minimum time appears for machine 2, process it last. So now next is, next higher minimum time is 3. So 2 3s are appearing. And unfortunately, both are for machine 2. So product E and G needs to be processed at last. But decision on which job will be taken first? Decision on which job needs to be taken first? In case of tie, because there is a tie here, na? In case of tie, see the process time of other machine. See the process time of other machine, and the job that requires lesser time compared to 7, this is the lesser time, na? In case of tie, see the process time of other machine, and wherever there is a minimum time, we take that decision first. Decision first means we will process E last and then G. One Indian author book gives opposite conclusion. That is not correct. I do not want to tell the name of that Indian author book because it is going on record. But they are wrong here. That they will process G last and E first. You check the machine idleness, actual thing will come out. In case of tie, we will see the process time of other machine, and we will take the decision on that job first wherever there is a minimum time. So E first. Next is 4. 4 appears at 2 places. So job D, there is no tie. So D will be processed last. Now for C and I, there is a tie here. C and I, there is a tie. In case of tie, see the process time of other machine. So 7 and 11. So minimum time is 7. So I will take decision on C first, then I. Next higher is 5. So 5 tie, and the second machine is also 8. Same. So B, H. There are alternate solution. HB and BH both are correct. But if the other machine time is also same, it means there are alternate solutions, either BH or HB, and the left out is F. So this is the sequence. This is the sequence. This is the sequence. Now, let us calculate the cycle time. How to calculate cycle time? Machine 1, machine 2. Because this is my sequence, write the sequence accordingly. ACI, BHF, DGE. Okay, same sequence I have written. There are alternate solution. Machine 1 in time, out time. Machine 2 in time and out time. So first A will get into the machine 1. So 0. We are starting with the 0 time. A consume, see very carefully, you see, A consume 2 unit time in machine 1. So after 2 unit time, it will come out of the machine 1. And after 2 unit time, it will get into machine 2. And job A consumes 6 unit time in machine 2. So 2 plus 6 is 8. After 8 unit time, job A will come out of machine 2. Correct? Machine 1 is available for use after 2 unit time. After 2 unit time. So C will enter into machine 1 after 2 unit time. C will enter into machine 1 after 2 unit time, and the C consumes 4 unit time. So 4 plus 2 is 6. Product C will come out of machine after 6 unit time, but machine 2 will be available only after 8 minutes. So this job is waiting for 2 minutes to be processed. And C consumes 7 unit time in machine 2. 7 plus 8, 15. Machine 1 is available for I after 6 unit time. I consumes 4 unit time in machine 1, so 6 plus 4 is 10. But for this product, machine 2 will be available only after 15 minutes. So 15 plus 11 is 26, because I consumes 11 unit time in machine 2. Understood now? Can you make the entire table? Giving you 30 seconds, because if I don't give you opportunity to do something, learning process will not be correct. Just 30 seconds. B, machine will be available after 10 minutes. B consumes 5, so 15, 26, 34. H will go after 15 minutes, consumes 5 minutes in machine A, 34 plus 8, 42. F will enter after 20 minutes in machine 1 and consumes 8 unit time, so 28. And it will enter 42. F 9, so 51. Correct now? The same procedure I am doing, it is better if you do on your own along with me. D consumes 9 minutes, 37, 51, 55, 37. G consumes 7 minutes, 55, 3, 44. E 6, 50, 58, and 3, 61. So cycle time is 61 minutes. Cycle time is 60 minutes. Okay? Cycle time is 61 minutes. Cycle time is 61 minutes. So just I want to take the, because I have to move the slide. 61 is the 61 minute is the cycle time. 61 minute is the cycle time. Now based on this data, this data is in a notebook. I have taken photograph of this. You know why? Because with this data, I want to prepare a Gantt chart. I want to prepare a Gantt chart. So every time I have to push back slide and all that. So I have taken photograph of the data. So you see this slide. I am preparing Gantt chart. Gantt chart for machine 1 and for machine 2. You know how the Gantt chart looks like this bar chart. Cycle time is 61 minutes. Cycle time is 61 minutes. So now I'm seeing the table. I'm seeing the table. Machine 1, 0 to 2 minutes, A is being processed. 2 to 6, C is processed. So it's continuous. It's continuous. Last one is 44 to 50, E is processed, and this is idle. In between there is no idleness, okay na? In between there is no idleness. Now for machine 2, 0 to 2 is idle. 2 to 8 is A. Same thing last. 58 to 61 is E. And in between there are many other things. Correct, na? There are many other things. So if you want to calculate percentage idleness of machine 1, 61 is the cycle time. How much time it is idle? 50 to 61, 11. 11 by 61 into 100. So percentage idleness of machine 1 is 18.04%. 18.04%. Or in other words, we can say the percentage utilization. That also we can say percentage utilization. 50 divided by 61 into 100 comes out to be 82% approximately, because both summations should be 100. Both summations should be 100. Now for machine 2, idleness only for 2 minutes it is idle. Divide by 61 into 100. Percentage idleness for machine 2 is around only 3.28%. Or you can say percentage utilization. Let us say 96.7%. Subtract basically in this. So these are called Gantt charts. Gantt charts give you complete picture about the percentage utilization and percentage idleness of the machine. So this problem we have done, it is multiple job, 2 machines problems. Multiple job, 2 machine problems. Okay. I think for some of you, you may have to see these lectures at least 1 or 2 times. Because if it is a live class, I could have known actually your problem and all these things I have taken care of. But because it is recorded one shot, so I don't know your problem. But once again, any type of problem you want to ask me, PW Telegram channel, please direct all the questions to me. Okay. So one more variety we will see. One more variety we will see. Multiple machines, multiple job problems. Multiple machines, multiple job problems. Jobs A, B, C, D. There are 4 jobs and there are 3 machines, M1, M2, M3. 4 jobs, 3 machines problem. 13, 5, 6, 7, 5, 3, 4, 2, 9, 7, 5, 6. 9, 7, 5, 6. Three machines, 4 jobs problems. Please hear carefully. Your GATE syllabus is limited. As I told you, if you opt for MTech Industrial Engineering, if you opt for MTech Industrial Engineering, you will not only write the programs, but more complexities will be added in these problems. And IIT Delhi, I don't know whether professor is there. We have very good professor of operations research at IIT Delhi. I don't know whether he is retired or still he is there. I don't know that, because most of my education is IIT Delhi, so I know all those teachers. Still, I am in contact with those teachers, some of them, those who are working. So, GATE only easy problems will come. Hear very carefully. If the number of machines are more than 2, if the number of machines are more than 2, you should know that the problem can be converted into artificial 2 machine problems. If the problem is appearing in GATE and other competitive examination, and if it is a more than 2 machine problem, 3, 4, 5, 6, any number, if you see my book, I have given many problems. Then multiple machine problems can be converted into imaginary 2 machine problems. How? See, if it so happens, maximum time of any machine maximum time of any machine is less than or equal to minimum time of any other machine. This condition must be existing. So here I can say maximum time of machine 1 is 5. Minimum time of machine 2 is also 5. So this condition is satisfying or no? Minimum time of machine M1 is 5 and maximum time of machine 2 is also 5. So that condition, na? Minimum M1 MJ minimum MI is greater than or equal to maximum mj. So this machine means m2 here. This machine I will add into remaining machines. This machine I will add up into another 2 machines. So here jobs A, B, C, D. So 2 machines are, let us say, machine X and machine Y. So M2 will be added, M1 plus M2, and here it's a M3 plus M2. Once these conditions satisfies this machine M2, their times will be added here and here. This will happen in every problem appearing in gate. If this condition is not satisfied, that is out of your course problem. That is out of your course problem. So 13 plus 5. 13 plus 5 is 18. 5 plus 9 is 14. 5 plus 3 is 8. 3 plus 7 is 10. 6 plus 4 is 10. 4 plus 5 is 9. 7 plus 2 is 9. 6 plus 2 is 8. Imaginary machine 1 and imaginary machine 2. Imaginary machine 1 and imaginary machine 2. Now, do the assignment, do the sequencing as per do the sequencing as per the normal procedure. Sequencing as per the normal procedure. Minimum is 8. If 8 appears for the first machine, I will process first. If 8 appears for the second machine, I will process it last. Next higher is 9. 9 appears for the second machine, so I will process last. And the BACD. BACD will be the sequence. BACD will be the sequence. BACD will be the sequence. After calculating the sequence, I will project on the original matrix. Machine 1, machine machine 3. The cycle time calculation I will not do on the imaginary machines. Imaginary machine I have calculated only just to get the sequence. This sequence I will project on the original matrix only. So now let us do this calculation. So first of all, B will enter into in time, out, in, out, in. Exactly the same way we have done in the previous problem. Now there is no change. This question was the only variety to show you how multiple machine problems can be converted into 2 machine problems. How the multiple machine problems can be converted into 2 machine problems. So now, first of all, B enters into the system. So 0 time. B consumes 5 unit time on machine 1. So after 5 minutes, it will come out of machine 1. And after 5 minutes, it will enter into machine 2. Machine 2 consumes 3 unit time. So 5 plus 3, 8. After 8 minutes, it will enter into machine 3. And machine 3 consumes 7 minutes. 8 plus 7, 15. Machine 1 is idle after 5 minutes. So after 5 minutes, job A will enter into machine 1. After 5 minutes, job A will enter into machine 1, and machine 1 consumes 13 unit time. So 13 plus 5 is 18. Now machine 2, it is available after 8 minutes. But next job will be available only after 18 minutes. So 18. So machine 2 will be ideal from 8 minutes to 18 minutes. So we have to be very, very careful while plotting the Gantt chart. Machine 2 will be ideal from 8 minutes to 18 minutes. A consumes 5 unit time on machine 2. So 18 plus 5, 23. Now the machine 3 will be idle after 15 minutes, but this will enter only after 23 minutes, consumes 9 minute time. So 32. After 18 minutes, product C will enter, and C consumes 6 unit time. So 18 plus 6 is 24. Machine is idle after 23 minutes, because the product will be available only after 24 minutes. 24 plus 4, 28. After 28 minutes, product is available, but machine will be idle only after 32. So after 32, product will enter, and it consumes 5 unit time, 37. Last product D will enter after 24 minutes, consumes 7 unit time, so 31. Again the machine 2 is idle for 3 minutes, consumes 2 minutes, 33. But machine will be available only after 37, so 37 directly it will enter into D, consume 6, 43. So cycle time is 43 minutes. Cycle time is 43 minutes. Now I will take again the photograph of this one. So now let us make the Gantt chart. Let us make the Gantt chart for machine 1, machine 2, and machine 3. So now same slide, from 0 to 5, 43 cycle time, B is working. 5 to 18, A is working. 18 to 24, C is working. 24 to 31, D is working. So idleness is 43 minus 31, or 12 minutes is average idleness on machine 1. So you can calculate percentage idleness or percentage utilization similar to the last problem. Now see machine 2, 0 to 5 minutes it is idle. Okay, na? 5 to 8, B is being worked. 8 to 18, Again it's idle. 18 to 23, A. 23 to 24, again it's idleness. And 24 to I'm looking my photograph, just you see whatever you have noted down in the last slide. 28, see, again 3 minutes idleness. 31 to 33, it's a D, and here again it's idle. 43. So to calculate the percentage idleness, this, this one, and this one needs to be added, divided by 43 will give you the percentage idleness. Now coming to machine 3, push. 0 to 8 it's idle. 8 to 15 it's a B. 15 to 23 is also idle. 23 to 32 it's a. 32 to 37, there is no idleness in between now. 32 to 37 it's a C, and 37 to 43 it is D. Correct? So here Gantt chart, you should know how the Gantt chart looks like, and if the number of machines are more than 2, you have to be bit careful about the Gantt chart. So what exactly we have done in this? What exactly we have done in this assignment and sequencing? Point number 1, assignment and sequencing problems are very, very easy because varieties are not possible. So whatever content we have discussed in this one-shot series, if you stick to it, 100% you will be able to attempt all the problems in GATE. So till now we have discussed 4 lectures: graphical, simplex, transportation, and assignment and sequencing, where if you know the procedure pretty much, you will be able to hit the question. Next 4 lectures are very good lectures because we have to focus more on the fundamentals. If the fundamentals are strong, you will be able to hit, because repetition doesn't come here. The coming 4 problems, repetition doesn't come. So I will take you dive into the fundamentals of the remaining 4 chapters. So keep logging into this English channel. We will discuss. If there is any doubt, let me know personally. Okay, na? Thank you very much. All the best.